Just before 1 o'clock in the morning on September 22, 1979, an American satellite saw something that should have had a simple explanation. A flash. Then darkness. Then a second flash. The satellite was more than 60,000 miles above the Earth. It was old. It had already survived far longer than anyone originally expected. But the instruments watching the planet below had been built for one very specific purpose: to catch countries testing nuclear weapons. And the pattern they had just recorded was disturbingly familiar. A nuclear explosion in the atmosphere does not usually appear to a sensitive detector as one simple burst of light. There is an initial, extremely intense flash. Then the expanding shock wave briefly blocks part of that light. Then, as the fireball grows and the atmosphere changes around it, the brightness rises again. Two peaks. A double flash. It is one of the fingerprints scientists learned to associate with an atmospheric nuclear detonation. And that was what the satellite appeared to have seen. Somewhere in an enormous stretch of ocean south of Africa, something had produced a signal that looked very much like a small nuclear weapon exploding. There was an immediate problem. Nobody had announced a test. The United States had not conducted one there. The Soviet Union had not announced one. Britain had not. France had not. China had not. And the location made the possibilities even stranger. The signal appeared to come from one of the emptiest regions on Earth. Cold ocean. Remote islands. Long distances from major population centers. A place where a ship could disappear over the horizon and be alone. If someone wanted to detonate a nuclear weapon without the world knowing who had done it, this was the kind of place they might choose. American officials began asking the obvious question: who had just tested a bomb? But before they could answer that, another question appeared. Had a bomb actually exploded at all? Because the more closely scientists examined the signal, the stranger it became. It looked nuclear, but not perfectly nuclear. The satellite that detected it was old. Other monitoring systems had not immediately produced the clear confirmation investigators expected. Aircraft searched for radioactive debris. Nothing decisive appeared. Seismic stations did not provide the answer. Reports of radioactive material in rainwater created excitement, then collapsed under examination. And some of the most respected scientists in America began considering an alternative that sounded almost ridiculous. What if there had been no explosion? What if sunlight had reflected from a tiny object passing near the satellite? A fragment of space debris. A small meteoroid. Something shaped and moving in exactly the right way to imitate one of the most important warning signals of the nuclear age. The disagreement divided the American government. Intelligence analysts leaned toward a nuclear test. Scientists advising the White House became increasingly skeptical. The CIA would later be described inside the administration as assigning a probability above 90% that a test had occurred. A presidential scientific panel refused to say that. Military laboratories continued searching. The Defense Intelligence Agency pushed back. Hydroacoustic evidence appeared months later. A strange disturbance had been detected in the upper atmosphere. Radioactive iodine would become another clue. And behind all of it were two countries whose names kept returning to the investigation: South Africa and Israel. One had already been caught preparing what American officials believed looked like a nuclear test site. The other maintained one of the most carefully constructed policies of nuclear ambiguity in the world. Both had reasons not to admit anything. Both had reasons not to be caught. And if the flash really was a nuclear test, neither has ever publicly admitted responsibility for it. More than 4 decades later, the event still has no universally accepted solution. The satellite saw something. The data survived. The document survived. The argument survived. But whatever happened in that remote stretch of ocean left behind no crater that investigators could visit. No government confession. No photograph of a bomb. No ship's captain stepping forward. No serial number. Just a double flash. and a mystery hidden inside two pulses of light. To understand why those two flashes mattered so much, we have to understand why the satellite was there in the first place. The Vela program was born from a problem created by nuclear diplomacy. In 1963, the United States, Soviet Union, and United Kingdom signed the Limited Test Ban Treaty. The treaty prohibited nuclear tests in the atmosphere, underwater, and in outer space. Underground tests could continue. The agreement was an enormous step away from the spectacular atmospheric testing of the 1950s and early 1960s. But treaties have a weakness. They depend on knowing whether somebody is cheating. The United States could sign a document saying atmospheric nuclear tests were forbidden. It still needed some way to know if the Soviet Union detonated a weapon thousands of miles away. So American scientists built eyes in space. Vela satellites. Pairs of them were placed in high orbits where they could watch huge areas of the Earth. The early spacecraft carried detectors for radiation produced by nuclear explosions. Later versions added optical instruments. Among them were devices known as bang meters. Their job was to watch for rapid changes in brightness. A lightning strike produces light. A meteor produces light. Sunlight reflecting from clouds produces light. War produces light. Nature produces an enormous number of things that can fool an instrument if all the instrument knows is that something became bright. So the challenge was not simply detecting flashes. The challenge was recognizing the shape of a nuclear flash. Scientists had an advantage. A nuclear fireball in the atmosphere produces a distinctive sequence. Immediately after detonation, the fireball becomes extraordinarily hot. Light surges. The blast wave develops. The atmosphere around the expanding explosion becomes opaque. Brightness drops. Then, as the shock front moves outward and conditions change, the visible fireball becomes exposed again. Brightness rises for a second time. The pattern looks like two humps. A quick first peak. A slower second one. The bang meter was designed to recognize that sequence. And the name itself became part of nuclear monitoring folklore. Whatever its linguistic origin, the instrument's job was very serious. It was supposed to tell Washington when someone had made a forbidden nuclear explosion. The satellites worked remarkably well. Every known atmospheric nuclear explosion occurring while the system was operating had been picked up by at least one Vela bang meter. That record mattered. A sensor becomes politically powerful when governments trust it. If a satellite signal could trigger accusations that another country had violated a nuclear treaty, the difference between a true signal and a false one mattered enormously. And on September 22, 1979, Vela 6911 produced exactly that problem. The spacecraft had been launched in 1969. By 1979, it was a veteran. Its instruments had operated well beyond their original design expectations. Some people would later look at that age and see an obvious weakness. Old electronics. Radiation exposure. Years in space. Could the satellite simply have malfunctioned? That would have been the easiest answer. The problem was that the experts who examined the event did not find that explanation convincing. The instruments had not merely generated random noise. They had produced a structured signal. Two optical detectors aboard the satellite responded. And the resulting shape looked remarkably like something the system had been built to recognize. A nuclear double flash. The location was initially imprecise. The sensors could establish that the source was somewhere within a vast region covering remote southern waters. This was not a spy satellite photographing a missile on a launch pad. There was no picture. No clear geographic pin. There was light-reaching sensors in space. Investigators had to use geometry, timing, and other monitoring systems to work backward. If this was a nuclear test, confirmation should exist somewhere else. That became the first major test of the nuclear hypothesis. A nuclear explosion is not only visible light. It produces radiation, sound, pressure, electromagnetic effects, radioactive debris. Depending on how and where it occurs, some of those signatures can travel enormous distances. So American monitoring systems began looking. Aircraft were sent to collect samples. The Air Force Technical Application Center had decades of experience detecting nuclear tests. The United States had discovered the Soviet Union's first atomic bomb in 1949 partly by sampling radioactive material in the atmosphere. The basic principle was straightforward. A nuclear explosion creates radioactive products. Wind moves them. Aircraft collect air. Laboratories examine filters and samples. Find the right isotopes in the right place at the right time, and a secret explosion becomes much harder to deny. But in the days after September 22, the atmosphere refused to provide a simple answer. No decisive cloud of fallout appeared. That absence immediately weakened the case. If a nuclear weapon had exploded in or near the atmosphere, where was the radioactive evidence? The answer could have been meteorology. The suspected region was enormous. Weather conditions mattered. The yield appeared, if the nuclear interpretation was correct, to have been relatively small. Clouds covered much of the region. A small, carefully placed detonation could produce debris that was difficult to intercept with limited sampling. But every explanation for missing fallout introduced uncertainty. And uncertainty is exactly what a clandestine test would need. Then came reports from New Zealand. Scientists appeared to have found unusual radioactivity in rainwater. For investigators hoping for physical confirmation, this could have been the missing evidence. Rain can pull radioactive particles from the atmosphere. If debris from a secret nuclear test had traveled eastward, rainfall might carry part of the signal to the ground. Samples were examined. Messages traveled through diplomatic and intelligence channels. Then the clue weakened. The measurements did not survive scrutiny as convincing evidence of the September event. A potential smoking gun became a false alarm. Now the skeptical case grew stronger. One satellite had seen a suspicious flash. But where was everything else? No clear fallout. No unambiguous seismic event. No country admitting anything. No observer reporting a mushroom cloud over the Southern Ocean. Maybe the answer really was that nothing nuclear had happened. But while one line of evidence was collapsing, another had already appeared thousands of miles away. Puerto Rico. The Arecibo Observatory was famous for its enormous radio telescope built into a natural depression in the landscape. Researchers there studied the ionosphere, the electrically charged region of the upper atmosphere. On September 22, Arecibo recorded a traveling disturbance. A wave moving through the ionosphere. Such disturbances can have many causes. The atmosphere and ionosphere are complicated systems. Earthquakes can generate waves. Weather can influence them. Solar activity matters. Explosions can also disturb the atmosphere. Officials at the Department of Energy looked at the Arecibo data and noticed something uncomfortable. Similar effects had been associated with nuclear detonations. If the timing and propagation were compatible with the Vela event, Arecibo might represent independent evidence that something energetic had actually happened. That would be important. One satellite can be wrong. Two unrelated systems detecting effects from the same event are harder to dismiss. But the Arecibo evidence was not clean enough to settle the question. The physics of traveling ionospheric disturbances was not sufficiently precise to point to one cause. The signal was suggestive, not definitive. The mystery accumulated another clue without gaining an answer. And while scientists argued over light and atmospheric waves, policymakers faced a much more immediate problem. If a country had secretly tested a nuclear weapon, who was it? The location pushed one suspect to the front almost immediately. South Africa. In 1979, South Africa was governed by the apartheid regime. International isolation was growing. The country faced military conflicts and regional instability. And, crucially, American intelligence already had reason to worry about South Africa's nuclear ambitions. 2 years before the Vela flash, the Soviet Union had approached the United States with alarming information. Soviet reconnaissance had detected activity in the Kalahari Desert that looked like preparation for a nuclear test. American intelligence examined the site. The conclusion was serious enough that President Jimmy Carter's administration confronted South Africa. Satellite imagery showed shafts and associated construction consistent with a possible underground nuclear testing facility. The United States wanted the work stopped. South African officials denied that the site was intended for a nuclear explosion. They gave assurances that South Africa would not conduct a nuclear test. International pressure intensified. The apparent preparations halted. But the question did not disappear. Why had the site existed? What exactly had South Africa been preparing to do? And had pressure merely changed where a future test might take place? A desert test site had disadvantages if secrecy mattered. Preparations could be photographed from space. Shafts could be inspected. Seismic signals could reveal an underground explosion. Evidence would remain afterward. The ocean offered something different. A small group could transport a device by ship. The test could occur far from population centers. The device could be detonated near the water. Cloud cover could hide the flash from human observers. Afterward, the ocean itself would eliminate much of the physical scene. There would be no obvious test shaft. No fenced desert installation. No crater accessible to inspectors. Only the signatures that remote monitoring systems could detect. That made South Africa an obvious suspect. And details from September 1979 attracted attention. Some South African naval facilities were operating under unusual conditions around the time of the flash. The naval base at Simonstown had been closed to ordinary access during a period that included September 22nd, although American reporting also noted that exercises there could explain the closure. A search and rescue unit at Saldanha Bay was reportedly placed on alert around the same period. Again, suggestive. Not proof. South African leaders also made remarks that became more suspicious once read through the lens of the Vela event. But ambiguous political language is dangerous evidence. A government surrounded by enemies may boast about secret capabilities for deterrence. That does not mean every boast is a confession. South Africa denied conducting the test. The country's atomic authorities produced atmospheric monitoring results that they said made a recent regional nuclear test unlikely. And decades later, when South Africa became the first country to build nuclear weapons and then voluntarily dismantle its arsenal, officials continued to deny that the country had conducted the Vela test. The later revelation of South Africa's nuclear program changed the historical picture dramatically. The suspicions of the 1970s had not been imaginary. South Africa really had been developing nuclear weapons. It eventually built a small arsenal. That fact makes the 1979 suspicion more understandable. But it does not prove South Africa detonated a bomb on September 22nd. Having the capability to do something is not evidence that you did it. And there was another suspect. One that created even more difficult political consequences for Washington. Israel. Israel's nuclear policy had long been built around ambiguity. It did not publicly acknowledge possessing nuclear weapons. It did not openly test one. It avoided the kind of declaration that would force allies and adversaries to react formally. This created a strange diplomatic arrangement. Everyone could understand what the hints meant. Intelligence services could make their own assessments. But governments could avoid saying certain things aloud. A visible nuclear test would threaten that arrangement. Once a country detonates a device and the event is attributed to it, ambiguity becomes much harder to maintain. That created a strong reason for Israel not to test openly. It also created, at least theoretically, a reason why any test it did conduct would need to be extraordinarily secret. American intelligence analysts considered Israel technologically capable of building nuclear explosive devices. If Israeli weapons designers wanted data from an actual detonation, a low-yield test in remote ocean waters could offer a path. But the risk would be enormous. Detection could damage Israel's relationship with the United States. It could create problems with Arab states. It could undermine diplomatic progress in the region. And September 1979 was an especially sensitive moment. Only 6 months earlier, Egypt and Israel had signed their peace treaty in Washington. President Carter had invested enormous political capital in that agreement. Imagine the consequences if, only months later, the United States announced that Israel had secretly detonated a nuclear weapon with another isolated regime. The political shock would be immediate. This point later fueled one of the most controversial interpretations of the entire Vela affair. Critics argued that the White House had reasons to prefer a non-nuclear explanation. Not because the scientists were ordered to falsify their work. There is no document proving a command like that. But because a finding that no test could be established made an enormous diplomatic problem disappear. If there was no confirmed nuclear explosion, Washington did not have to identify a culprit. If there was no culprit, it did not have to decide what sanctions or diplomatic response should follow. If Israel was involved, the administration could avoid confronting one of the most politically explosive questions in American foreign policy. This is where the Vela mystery becomes two mysteries. The first is physical. What produced the flash? The second is institutional. Did politics influence how the physical evidence was interpreted? The answer to the second question depends heavily on which documents you read. Because the American government did not speak with one voice. In the weeks after the flash, some intelligence and scientific assessments strongly favored the nuclear interpretation. One CIA-sponsored group of experts concluded that the signals were consistent with an atmospheric nuclear explosion. Richard Garwin, one of America's most respected physicists, initially leaned toward the same answer. Garwin was not a conspiracy theorist. He had worked on nuclear weapons questions for years and served on major national security advisory panels. After examining the early evidence, he reportedly placed his personal odds around 2-to-1 in favor of a nuclear explosion. That sounds significant. But Garwin would later change his mind. And his change became one of the most fascinating details in the case. Why would an expert who initially saw a nuclear test become willing to sign a report saying a test was probably not the most likely explanation? The answer brings us to the panel created by White House science advisor Frank Press. By late October 1979, the story was becoming impossible to contain. News organizations were learning that an American satellite had detected a possible nuclear event. The administration needed an authoritative technical assessment. Press assembled 8 distinguished scientists. Jack Ruiner of MIT chaired the panel. Their assignment was narrow. Study the signal. Study alternative explanations. Determine whether the evidence established that a nuclear explosion had taken place. This sounds straightforward. It was not. The panel began with an uncomfortable fact. The September 22 signal really did look like a nuclear explosion. In its eventual findings, the panel acknowledged that explicitly. Among all the non-nuclear signals Vela had recorded, this one resembled a nuclear event more closely than anything else. That sentence alone explains why the incident never disappeared. The skeptics were not saying the signal looked ordinary. They were saying that despite how nuclear it looked, something about it did not fit perfectly. The detailed shape contained a discrepancy. The relationship between portions of the light curve differed from known nuclear events. That mattered because the entire point of the bangmeter system was pattern recognition. A flash that is almost right may be evidence of an unusual nuclear geometry. Or it may be evidence that the event was something else entirely. The panel then examined non-nuclear possibilities. Lightning. Rejected. Various natural optical phenomena. Rejected. A technical failure inside the satellite. Also rejected. That is important. The White House panel did not conclude that Vela 6911 had simply broken. Instead, they focused on a far stranger possibility. Sunlight reflecting from a small object near the satellite. Imagine a tiny meteoroid passing through space. Not entering Earth's atmosphere as a bright meteor. Passing near the spacecraft itself. If its shape, surface and motion were unusual enough, sunlight could reflect toward the optical sensors in 2 distinct pulses. A tumbling fragment could brighten, dim and brighten again. Computer models suggested that an object with the right characteristics could produce something resembling the recorded signal. One description compared the hypothetical object to a fractured ball bearing. The idea sounded improbable. The panel knew that. But the nuclear hypothesis now had its own improbability. Where was the corroborating evidence? The Vela network had seen many known nuclear tests. Those events had been confirmed through other channels. Here, the supposedly nuclear signal stood largely alone. No decisive fallout. No definitive seismic event. No confirmed human observation. The panel found itself choosing between two unlikely stories. A secret nuclear explosion that somehow escaped clear independent confirmation. Or the first known space object to generate a nuclear-like double flash after years of Vela observations. The scientists refused to assign clean probabilities. Instead, they reached a carefully worded conclusion. They could not determine whether a nuclear explosion had occurred. The signal had the general characteristics of one. But the discrepancy and lack of corroboration raised enough doubt that the nuclear explanation could not be established. In later descriptions, the panel's view was often simplified into something stronger. The flash was not nuclear. That is not exactly what the panel said. Its conclusion was closer to a Scottish legal verdict of not proven. Maybe nuclear. Maybe not. The evidence did not meet the standard the panel wanted. But in Washington, uncertainty can function like a decision. If the government cannot establish that a treaty violation occurred, policy can proceed as though no proven violation exists. And that is what happened. The panel's conclusion became the closest thing the United States had to an official public position. The September 22 event remained unresolved. South Africa could be approached without a formal accusation. No public confrontation with Israel was required. The administration could say the evidence was inconclusive. For some people inside the intelligence community, this was infuriating. They believed the scientists had focused too heavily on weaknesses in the optical data while dismissing evidence pointing the other way. The split would become deeper during 1980. One internal White House memo captured the mood with a line that later became infamous. Officials from the Energy and Defense departments were going to be allowed to present their case for a nuclear event so that White House staff could, in effect, dismiss it more confidently afterward. Whether that reflected bias, bureaucratic frustration, or simply confidence in the panel's work is open to interpretation. But it shows how divided the government had become. This was no longer only a scientific question. It had become an argument among institutions. The White House science advisors had one conclusion. Elements of the CIA had another. The Defense Intelligence Agency had another. National laboratories had concerns. And each group believed the others were giving too much weight to the wrong evidence. Then a new clue emerged from somewhere the Ruina panel had not expected to settle the case. The ocean itself. When an explosion occurs at or near the surface of the sea, energy enters the water. Sound travels through ocean water extremely efficiently. At certain depths, temperature and pressure can create channels that allow low-frequency acoustic energy to travel enormous distances. Navies use this property. Scientists use it. And nuclear test monitoring systems can use it. The U.S. Naval Research Laboratory examined hydroacoustic recordings from September 22. The analysis produced a disturbing result. Signals existed that analysts believed were characteristic of a nuclear explosion in a maritime environment. Even more important, the acoustics appeared capable of narrowing the location. Not the entire South Atlantic. Not an enormous oval thousands of miles across. A region near two remote islands. Prince Edward Island and Marion Island. South African territory. They sit deep in the southern Indian Ocean, far south of the African continent. Cold. Windy. Remote. Exactly the kind of place where very few witnesses would exist. For Defense Intelligence Agency officials who already believed the optical signal was nuclear, the hydroacoustic evidence looked like confirmation. Jack Verona, a senior DIA scientific intelligence official, became one of the strongest internal critics of the White House conclusion. He argued that the acoustic signals analyzed by the Naval Research Laboratory were distinctive of nuclear shots in a maritime environment. In his view, the mystery had effectively been solved. A nuclear explosion had occurred. The White House panel had simply reached the wrong answer before important evidence became available. That timing matters. Science is only as good as the data available when a conclusion is made. The Ruina panel completed much of its work before the later hydroacoustic analysis had matured. If the acoustic evidence was as strong as DIA believed, then the panel's most powerful argument, lack of corroboration, had weakened. Now there were two systems: optical and acoustic. Possibly a third if Arecibo's ionospheric disturbance was connected. And then came evidence from animals. Sheep. It sounds almost absurd that an international nuclear mystery involving spy satellites and intelligence agencies could turn on sheep thyroid glands. But radioactive iodine is exactly the kind of substance nuclear monitoring specialists care about. Iodine-131 is produced in nuclear fission. It has a relatively short half-life. That means finding unusual amounts can point to a recent event rather than contamination left over from decades earlier. Animals grazing on contaminated land can ingest it. The iodine concentrates in the thyroid. Scientists routinely examining sheep thyroids therefore had a biological sampling system scattered across large areas. After the Vela event, unusual iodine-131 levels were reported in sheep from southeastern Australia. The animals had grazed in an area where rain had fallen several days after September 22nd. If radioactive material from a Southern Ocean test had entered the atmosphere, traveled east and been washed down by rain, sheep could theoretically ingest it. This was not proof. Industrial and medical sources had to be considered. Radioactive iodine exists outside nuclear weapons testing. Investigators needed to establish whether local sources could explain what was found. But once again, the pattern of the Vela case repeated itself. A clue appeared. It leaned toward nuclear. Then uncertainty surrounded it. The evidence did not deliver a confession. Instead, it made the non-nuclear explanation harder to accept cleanly. By this point, the question was no longer whether any evidence supported a nuclear test. Plenty did. The question was whether the pieces truly belonged to the same event. A suspicious optical signal. An ionospheric disturbance. Hydroacoustic signals. Radioactive iodine. A region containing a state with an emerging nuclear weapons program. Possible links to another state believed capable of building nuclear weapons. Each piece looked important. But intelligence analysis has a dangerous trap. Once investigators favor a theory, unrelated facts can begin looking connected simply because they fit. This is confirmation bias on a national security scale. If you believe a nuclear test occurred, every strange measurement after September 22nd becomes potential fallout. Every naval exercise becomes preparation. Every political remark becomes a hint. Every unusual isotope becomes evidence. The correct question is not whether a clue fits. It is whether the clue is more likely if the theory is true than if it is false. The same problem existed on the skeptical side. Once scientists favored a meteoroid explanation, were they too willing to dismiss evidence that pointed back toward nuclear? The Vela mystery became a battle over standards of proof. What would it take to say yes? What would it take to say no? And who should make that decision? Meanwhile, the CIA was conducting an entirely different kind of analysis. Instead of asking whether an explosion happened, one interagency study was instructed to assume that it had. Then analysts asked who could have done it. That distinction is important. The study did not prove a nuclear test by identifying a suspect. It began with a nuclear hypothesis and explored consequences. The analysts estimated that, if the event was a test, the yield was probably below a few kilotons. Small by Cold War standards. A Hiroshima-type weapon was around 15 kilotons. Thermonuclear weapons could reach megatons. A device below 3 kilotons would be relatively modest. But that could make sense for secrecy. A lower yield means less dramatic physical evidence. Less light. Less fallout. Less chance of distant seismic detection. And a small test could still provide useful engineering data. If a country wanted to verify a new design without announcing itself as a nuclear weapon state, a low-yield ocean test was plausible. The analysts considered established nuclear powers. The Soviet Union theoretically could have conducted a secret test, but the political risk would have been enormous. France and China had other established testing options and little obvious reason to create this kind of clandestine mystery. Britain and the United States clearly did not need a secret anonymous test in the Southern Ocean. Attention returned to emerging nuclear states. India had already demonstrated a nuclear explosive in 1974. Pakistan was moving toward a weapons capability but was not believed ready for this event. Taiwan had attracted proliferation concerns but lacked key requirements. South Africa and Israel remained the central possibilities. And between them, a particularly provocative theory emerged. What if the test was a joint operation? South African logistics. Israeli device. A remote region under South African access. Shared secrecy. The attraction of the theory is obvious. It solves problems for both sides. Israel gets a place to test far from home. South Africa provides geographic access and support. South Africa may gain technical knowledge or political value in return. If discovered, responsibility remains ambiguous. A flash near South Africa naturally points toward Pretoria first. Israel remains one step removed. But elegant theories are not necessarily true. The evidence for a joint test is circumstantial. There is evidence that Israel and South Africa maintained military and technological relations during the apartheid era. There are documents demonstrating American concern about nuclear cooperation. There are later historical claims of deeper collaboration. But no publicly available document contains the line investigators would most want. An order. A test plan. A ship's log. A device serial number. A message saying the bomb was detonated successfully on September 22nd. The central evidence remains the event itself. This is why attribution is even harder than deciding whether the flash was nuclear. You could reach 99% confidence that a nuclear explosion occurred and still not know who detonated it. A clandestine ocean test is designed to separate the event from the perpetrator. No flag on the fireball. No national signature in the light curve. Physics tells you what happened. It does not tell you who gave the order. This distinction became politically useful. Some American officials could privately believe a test had occurred while publicly avoiding attribution. And President Carter's own private writings suggest his thinking evolved. On the day of the event, his possibilities included South Africa, Israel operating at sea, or no nuclear test at all. By February 1980, Carter privately recorded a growing belief that Israel had indeed conducted a nuclear test near southern Africa. That entry is striking. The president whose administration's scientific panel had refused to confirm a nuclear event was privately leaning toward one of the most politically sensitive explanations. It does not prove Carter had secret evidence unavailable today. Presidents receive intelligence of varying quality. His belief could have been based on the same disputed material others were debating. But it demonstrates that the official ambiguity did not necessarily reflect private certainty. Inside government, different versions of reality could coexist. Publicly, inconclusive. Scientifically, disputed. Intelligence assessment, probably nuclear. Presidential suspicion, possibly Israeli. Diplomatic policy, avoid a claim that cannot be proven. This layered uncertainty is one reason conspiracy theories grew around the Vela incident. Whenever the public position is less certain than the private assessments, suspicion follows. People ask what officials are hiding. Sometimes the answer is a cover-up. Sometimes the answer is simply that intelligence agencies assign probabilities while governments need evidence they can defend publicly. Those are different standards. An intelligence analyst can say there is an 80 or 90% chance country X did something. A president deciding whether to accuse an ally of violating nuclear agreements may need more than 90%. Especially when the remaining 10% could trigger a major diplomatic crisis. This is an important distinction. Uncertainty can look like dishonesty from the outside. But governments routinely act under uncertainty. The Vela incident sat at the worst possible intersection. The evidence was strong enough to alarm, weak enough to dispute, and the political consequences of certainty were enormous. Then there is the satellite itself. The skeptical case often begins with its age. Vela 6911 was 10 years old. Its nominal design life had long expired. It had spent a decade in a hostile radiation environment. Surely that matters. It does. But age does not automatically mean failure. The White House scientific panel examined the possibility of a technical malfunction and did not adopt it as the explanation. The sensors appeared to have responded to an external optical event. So anyone arguing against a nuclear explosion still needed an actual physical phenomenon capable of generating the strange light curve. That is why the meteoroid theory mattered. Not because a satellite glitch was an easy escape. Because a small object reflecting sunlight could theoretically create a real signal without any explosion on Earth. The panel had evidence that Vela bang meters had recorded hundreds of thousands of triggers during their operational lives. Most had mundane explanations. Lightning, charged particles, other phenomena. There was also a class of unexplained signals sometimes described informally as zoo events. Strange things lived in the data. The world and space environment were more complicated than the clean categories engineers wanted. If you operate sensitive instruments long enough, eventually they see something unprecedented. That principle is powerful. Suppose a system has monitored Earth for 10 years without one particular type of false alarm. It is tempting to conclude that such a false alarm is impossible. But 10 years is not infinity. Rare events happen. The first one, by definition, arrives without precedent. The panel's challenge was deciding whether September 22 was the first extraordinary false alarm or an extraordinary secret nuclear test. Both were rare. The meteoroid theory required coincidence. An object with appropriate size and reflective properties, passing near the satellite, at the right geometry relative to the Sun, producing two brightness peaks, triggering both sensors in a way that resembled a nuclear event. That sounds fantastically unlikely. But a clandestine nuclear test with no obvious fallout also required a chain of favorable circumstances. Remote location, low yield, weather, successful secrecy, missed sampling, no witnesses, no later confession. The panel could not assign meaningful probabilities to two events that were both rare and poorly characterized. So it stopped. Not proven. That is scientifically defensible. But later analysts attacked one part of the logic. They argued that the optical signal itself contained more nuclear information than the panel had credited. Researchers revisited how clouds, sea surface reflections, and detector geometry could alter the apparent shape of a real nuclear flash. If cloud cover or ocean conditions distorted the signal, then the discrepancy that worried the Ruina panel might not require a non-nuclear explanation. A nuclear explosion viewed indirectly can look different from a textbook test observed under ideal conditions. The suspected region was heavily clouded. That could help explain two mysteries at once. Why the flash looked unusual, and why human witnesses were absent. Clouds would also complicate optical detection from multiple satellites depending on geometry. The environment itself could turn a genuine nuclear signal into an imperfect one. Then the later hydroacoustic work became even more important. Light can be distorted by clouds. Sound traveling through the ocean follows completely different physics. If both independently point toward a single event, coincidence becomes harder to defend. Modern researchers sympathetic to the nuclear interpretation often describe the evidence as resting on several pillars. The optical double flash, radioactive iodine, hydroacoustic evidence, The Arecibo disturbance is another supporting clue. None alone provides the name of a perpetrator. Together, advocates argue, they make the meteoroid explanation increasingly strained. But even modern reanalysis faces limits. The original event cannot be repeated. Sensors from 1979 cannot be upgraded. Weather data contain gaps. Some intelligence remains classified. Physical samples were limited. The suspected ocean site was never investigated like a conventional crime scene. And any radioactive trace from a small 1979 test has long since dispersed or decayed. Time does not always solve mysteries. Sometimes it destroys the remaining evidence. This leaves us with an unusual historical problem. We may have more documents today than officials had access to in any single office in 1979. Declassification lets us read State Department cables, White House memoranda, intelligence assessments, scientific arguments, diplomatic preparations. We can see disagreements that were once compartmentalized. But more paper does not necessarily create more physical evidence. The event remains two flashes of light. Everything else is inference built around them. So what would the perfect piece of evidence look like? A South African archival document ordering naval support for a test. An Israeli technical record specifying the date and location. A surviving crew member's authenticated log. A weapons program file describing the device and its yield. A signal intercept explicitly reporting success. Any one of those could transform the debate overnight. None has publicly emerged. South Africa is particularly interesting because its nuclear weapons program was later open to international scrutiny in a way almost no secret nuclear program has been. In the early 1990s, President F.W. de Klerk revealed that South Africa had built nuclear weapons and then dismantled them. The International Atomic Energy Agency verified the dismantlement program and inspected relevant nuclear material. South Africa had built 6 completed nuclear weapons, with another under construction when the program ended. This confirmed that the country suspected in 1979 really did become a nuclear weapons state. Yet South African officials maintained that the arsenal had never been tested explosively. The design used highly enriched uranium in a gun-type configuration. A gun-type weapon is conceptually simpler than an implosion weapon. One portion of fissile material is rapidly driven into another to create a supercritical assembly. The basic design can provide high confidence without a full-scale nuclear test. The United States had used a gun-type uranium bomb over Hiroshima without first testing that exact design in a nuclear explosion. So South Africa did not necessarily need Vela as a weapons-proof test. That weakens one motive. But it does not eliminate the possibility of a test connected to another country or another design. Israel presents the opposite archival problem. Its policy of nuclear opacity continues. There has been no official Israeli declaration revealing a historical test program that can be compared with the Vela date. That means the most direct possible archive remains unavailable or may not exist in accessible form. The lack of acknowledgement keeps the theory alive indefinitely. And this is where historical mystery can become politically dangerous. There is a difference between evidence and narrative momentum. The longer a mystery remains unresolved, the more attractive the strongest available story becomes. Israel plus South Africa offers characters, motive, means, location, diplomatic stakes, possible cooperation, secrecy. It feels complete. The meteoroid theory feels unsatisfying because it has no human actor. No plot. No reason. Just random geometry. Human beings prefer explanations with intention. But nature does not care whether a story is satisfying. A bizarre reflection can happen. An unusual sensor event can happen. A meteoroid does not need motive. So any responsible conclusion has to resist storytelling instinct. We have to ask what the evidence can actually carry. Start with the strongest fact. Vela 6911 detected a double flash. That is confirmed. The White House panel itself agreed that the signal had the general character of a nuclear explosion. Confirmed. The panel also found a discrepancy compared with known nuclear signals. Confirmed. It could not identify a definitive non-nuclear cause. Confirmed. It considered a meteoroid or space debris reflection physically possible. Confirmed. It did not establish that such an object had actually been present. Also confirmed. Air sampling did not produce decisive fallout evidence. Confirmed. Arecibo recorded an ionospheric disturbance considered potentially relevant. Confirmed. The connection between the disturbance and the Vela event was not proven. Hydroacoustic signals were later interpreted by Naval Research Laboratory and DIA experts as consistent with a maritime nuclear event. Confirmed as an interpretation. Whether that interpretation uniquely proves a nuclear detonation remains disputed. Radioactive iodine was detected in Australian sheep after the event. Confirmed in declassified reporting. Whether the iodine came from the suspected test was not proven. South Africa had an actual clandestine nuclear weapons program. Confirmed years later. South Africa had been confronted about suspected test preparations in the Kalahari in 1977. Confirmed. South African responsibility for the September 1979 event. Not confirmed. Israel possessed the technical capability that made it a serious intelligence suspect. Strongly supported by contemporary American assessments. Israeli responsibility. Not confirmed. A joint Israeli-South African test. Plausible hypothesis. Not established fact. A nuclear explosion itself. This is where the mystery remains. The evidence leans more strongly in that direction than the simple phrase, "unexplained flash" suggests. Many people inside the American intelligence and nuclear monitoring establishment believed a nuclear test had taken place. The CIA's probability estimate described in White House records was extremely high. DIA officials later regarded the hydroacoustic evidence as decisive. President Carter privately moved toward believing Israel was involved. Later technical researchers have continued arguing that the nuclear interpretation best explains the combined evidence. But the White House Scientific Panel's central objection has never completely vanished. A truly convincing nuclear event should create independent signatures. And in early 1980, the panel did not believe those signatures had been clearly tied together. That is why the Vela incident remains a mystery instead of becoming a historical fact with a footnote. The standard for saying probably is different from the standard for saying proved. And perhaps the most interesting question is what the United States would have done if proof had arrived. Imagine that an aircraft had collected unmistakable radioactive debris. Laboratory analysis identifies fresh fission products. Atmospheric modeling traces them back to the suspected ocean region. Intelligence intercepts connect a South African ship with Israeli personnel. The event becomes undeniable. Washington would have faced a crisis. A state outside the accepted nuclear powers had conducted a clandestine atmospheric nuclear test. International agreements had been challenged. American non-proliferation policy would be on the line. If South Africa were responsible, the apartheid regime had demonstrated a nuclear weapon despite intense pressure from Washington. If Israel were responsible, one of America's closest regional partners had crossed a line Carter had spent years trying to prevent other countries from crossing. If both were involved, Washington would face a secret nuclear partnership with enormous political consequences. What sanctions should follow? What should allies be told? What should the Soviet Union be told? Should the evidence be presented publicly? Would disclosure reveal sensitive American detection capabilities? Could the United States prove attribution strongly enough to survive denials? Every one of those questions disappears if the answer to the first question remains uncertain. Did a test happen? We cannot prove it. That does not mean officials deliberately engineered uncertainty. But uncertainty was politically convenient. And political convenience is why the controversy around the Ruina panel never disappeared. Critics accused the panel of a whitewash. That is a serious accusation. The evidence for political pressure is suggestive rather than definitive. We know senior officials understood the diplomatic consequences. We know White House staff were dismissive of dissenting scientific agencies in internal language. We know important intelligence organizations remained unconvinced by the panel. We know Carter himself later privately suspected an Israeli test. What we do not have is a document from the president telling the scientists what conclusion to reach. Without that, the strongest responsible interpretation is more subtle. Political stakes shape the environment in which the science was being interpreted. That happens constantly in government. Scientists may work honestly while policymakers prefer one result. Intelligence agencies may emphasize evidence according to their institutional missions. A weapons laboratory asks whether a signal could represent a nuclear event. A diplomatic office asks whether the evidence justifies confronting another government. A scientific panel asks whether alternative natural explanations can be excluded. They are not always answering the same question. This may explain part of the Vela disagreement without requiring a conspiracy. The intelligence community could rationally say probably nuclear. The scientific panel could rationally say not proven. The White House could rationally choose the second formulation for public policy. All three positions could coexist. But there is another possibility. One side was simply wrong. Maybe a small nuclear weapon exploded near the Prince Edward Islands and the Ruina panel talked itself out of the obvious answer. Or maybe an unprecedented optical event occurred near an aging satellite and intelligence analysts built an enormous geopolitical theory around two reflections of sunlight. Both stories are possible. Only one can describe what actually happened. The mystery becomes even stranger when we consider what the perpetrators, if there were perpetrators, would have known. Any country capable of secretly testing a nuclear weapon in 1979 would know about American detection systems. Vela was not a secret in the broad sense that satellites existed to monitor nuclear tests. A sophisticated weapons program would understand that an atmospheric or near-surface detonation might be seen from space. So why test there? Why risk it? One answer is weather. Cloud cover. If the device was placed under thick clouds, direct optical detection could be reduced. Another is yield. Keep the explosion small. Another is location. Choose remote ocean far from sampling stations. Another is ambiguity itself. Maybe the goal was not to make detection impossible. Maybe the goal was to make attribution impossible. Those are different objectives. A country may accept that the United States will know something happened as long as Washington cannot prove who did it. This is a classic intelligence strategy. Plausible deniability does not require perfect invisibility. It requires enough uncertainty that punishment becomes difficult. If that was the plan, the Vela event was extraordinarily successful. The satellite saw it. Intelligence agencies suspected it. Scientists argued. The president worried. Newspapers reported. And still, nobody could publicly identify a perpetrator with proof. More than 40 years later, the same uncertainty remains. But consider the opposite. If the event was a meteoroid, it accidentally produced almost the perfect signature for creating an international nuclear crisis. It passed near the right satellite. Produced the right pattern. At a time when South Africa was already under nuclear suspicion. Near a region politically connected to that suspicion. Then unrelated atmospheric, acoustic and radioactive anomalies appeared close enough in time for investigators to connect them. That is also an extraordinary coincidence. Mysteries survive when every explanation has something uncomfortable about it. The Vela incident has that property. The nuclear theory struggles with missing direct fallout and lack of confession. The meteoroid theory struggles with the remarkable resemblance of the optical signal and later supporting evidence. The South African theory struggles with motive and later official denial despite unusual transparency about the rest of its dismantled weapons program. The Israeli theory struggles with lack of direct documentation. The joint test theory struggles with both. Every path reaches a gap. And that gap is where speculation lives. There is one more piece of the story that deserves attention. The Vela system itself helped transform science. Satellites built to detect nuclear explosions repeatedly saw phenomena nobody expected. Some mysterious bursts were eventually discovered to come from deep space. Gamma-ray bursts. For years, these flashes had confused military sensors. The instruments designed to watch human beings destroy one another helped reveal some of the most violent events in the universe. That history is a reminder. Sensitive detectors often discover worlds their designers did not anticipate. The fact that Vela saw something strange does not automatically make that something a bomb. Nature is capable of producing signals outside our expectations. That strengthens the skeptical lesson. But the gamma-ray burst story also contains the opposite lesson. Scientists solved those events by finding patterns across multiple satellites. They localized them. They accumulated evidence. The unexplained became explainable. The September 22 flash never received that luxury. It was one event. One moment. One aging satellite. One chance. History rarely gives investigators controlled experiments. The signal happened once and disappeared. No repeat. No opportunity to reposition instruments. No ability to collect another sample from the same explosion. Everything depended on the network already in place. This is why modern nuclear test monitoring uses multiple technologies. Seismic sensors. Hydroacoustic stations. Infrasound. Radionuclide monitoring. Satellites. No single sensor should carry the entire burden. One signal can be ambiguous. Multiple independent signals allow confidence to rise dramatically. Vela helped teach that lesson. The 1979 event exposed how dangerous it was to ask one satellite's optical sensors to make a geopolitical judgment. The Ruina panel said as much. Without corroboration, a single satellite's bang meters should not be considered definitive evidence for one event. That conclusion has implications beyond the mystery itself. Imagine a future crisis. Two nuclear powers are already tense. A satellite reports a suspected explosion. Leaders have minutes or hours to decide what it means. Is it a test? An attack? A malfunction? Natural phenomenon? The quality of detection systems becomes part of nuclear stability. False alarms are not merely technical annoyances. They can influence wars. The Vela flash was fortunate in one respect. It occurred in a remote region and did not resemble an attack on the United States or Soviet Union. Officials had time. Days. Weeks. Months. Scientists could debate. Aircraft could sample. Panels could meet. Imagine the same ambiguity during a missile warning. There would be no luxury of a Ruina committee. Detection technology is therefore not only about catching cheaters. It is about preventing uncertainty from becoming catastrophe. In that sense, September 22 was a warning even if no nuclear bomb exploded. The sensor network had encountered an event it could not confidently classify. And classification was exactly what it existed to do. The mystery exposed the limits of surveillance. People often imagine spy satellites as nearly omniscient. Machines in space that see everything. The reality is more complicated. Sensors do not see truth. They collect measurements. A voltage. A photon count. A waveform. A timestamp. Human beings turn those measurements into meaning. The bang meter did not transmit the sentence, South Africa and Israel just conducted a secret nuclear test. It transmitted a light curve. Everything after that was interpretation. Physics. Statistics. Intelligence. Politics. History. The distance between measurement and conclusion is where the Vela mystery exists. Two experts can look at the same graph and agree completely about its shape while disagreeing about its cause. That is not necessarily failure. It is how science works when evidence is incomplete. What makes Vela unusual is what depended on the answer. If astronomers disagree about the cause of a distant flash, they publish papers. If national security scientists disagree about whether an ally secretly detonated a nuclear weapon, governments may fall into crisis. The stakes amplify every disagreement. That pressure can make people more careful. It can also make institutions defensive. Nobody wants to accuse a country incorrectly. Nobody wants to overlook a nuclear test. Those risks point in opposite directions. One encourages skepticism. The other encourages suspicion. The Vela case sits between them. So where does the evidence point today? If we remove the politics and examine only the physical clues, the nuclear interpretation is strong. The optical signal is the centerpiece. The very panel skeptical of a test acknowledged that it looked exceptionally nuclear. A non-nuclear reflection remained possible but unusual. The Arecibo disturbance offers suggestive independent evidence. Hydroacoustic analysis later supplied a more direct physical pathway to a maritime explosion near South African territory. Radioactive iodine provides another possible trace. Modern reanalyses have generally strengthened rather than weakened the case that a nuclear event occurred. That does not create certainty. But if this were an ordinary historical investigation rather than a question carrying nuclear and diplomatic consequences, many researchers would probably describe the nuclear explanation as the leading one. The harder question is attribution. South Africa alone? Israel alone? Joint operation? Something else? Here the confidence falls sharply. South Africa clearly had a nuclear program. Israel was widely assessed as nuclear capable. Both had access, motive, and reasons for secrecy that can be constructed plausibly. But possibility is not identification. No physical characteristic of the flash tells us whose bomb it was. No publicly available sample has been tied to a particular weapons program. No government document closes the loop. Even Carter's suspicion remains suspicion. That means the responsible answer has two layers. What happened? Probably, though not conclusively, a nuclear test. Who did it? Unknown. And that second answer may never change. Governments can keep secrets for decades. But people die. Archives disappear. Records are destroyed. Programs close. Ships are scrapped. Oral knowledge vanishes. South Africa's nuclear program was dismantled more than 30 years ago. Many people who would have known the details of a 1979 operation are gone. If Israel was involved, the policy of opacity creates little incentive to clarify a mystery that has already survived for decades. Why confess now? There is no strategic benefit. Silence has worked. This creates one of history's strangest possible outcomes. A country may have detonated a nuclear weapon. The world's most sophisticated monitoring system may have detected it. The world's most powerful intelligence agencies may have identified the event as probably nuclear. The President of the United States may have privately suspected who did it. And yet the event can remain officially unresolved forever. Not because nobody noticed. Because noticing and proving are different things. That distinction defines intelligence work. A spy service is often paid to tell leaders what is probably true before courtroom quality proof exists. Policy must then decide what to do with probability. 90% sounds high. If your doctor tells you there is a 90% chance of a disease, you act. If weather forecasters give a 90% chance of a hurricane strike, governments prepare. But if you are about to publicly accuse an ally of conducting an illegal nuclear test, 90% may not feel high enough. The cost of the remaining 10% becomes enormous. So uncertainty protects the suspect. This may have been the genius of a clandestine test, if that is what Vela saw. The perpetrators did not need to defeat American sensors. They only needed to defeat certainty. The satellite could see the flash. Aircraft could hunt fallout. Scientists could argue. Intelligence officers could reach private conclusions. None of that mattered if no one could place a flag beside the explosion. And the location itself was almost designed for ambiguity. Look at a globe. Move south from Africa. The continent narrows. then ends. Beyond it is ocean. Thousands of kilometers of water. The Prince Edward Islands sit alone in that vast space. Marion Island is larger. Prince Edward Island smaller. South African territory, but far removed from mainland scrutiny. The climate is harsh. The seas are rough. Clouds are common. Human presence is tiny. A low-yield device detonated somewhere in that environment would have few accidental witnesses. No city skyline. No commercial harbor full of cameras. No population hearing the blast. In 1979, there were no smartphones. No civilian satellite imagery available to millions of internet users. No global social media network where sailors could post video within minutes. A secret that required dozens of disciplined people could still remain a secret. And a ship can leave almost no permanent trace of what happened on open water. If investigators arrived weeks later, where would they look? An ocean current does not preserve fingerprints. The atmosphere does not keep evidence stationary. Radioactive material disperses. Weather erases. Water dilutes. The environment itself becomes part of the concealment. This is why the absence of a crime scene matters so much. Most historical mysteries at least leave a place. A room. A wreck. A grave. A field. Vela leaves coordinates with enormous uncertainty. You cannot dig up the answer. The event has no accessible body. Only signals. It is a mystery made almost entirely of data. And perhaps that is why it feels so modern. We increasingly understand the world through sensors. Satellites tell us where fires burn. Radar tells us where aircraft fly. Seismic networks tell us where earthquakes begin. Algorithms tell us when something unusual happens. But every sensor has an interpretation problem. What does the anomaly mean? Vela 6911 did exactly what it had been built to do. It noticed the anomaly. The unresolved part belongs to us. So imagine the final moments again. Somewhere south of Africa, if the nuclear theory is correct, a small group of people is aboard one or more ships. The weather is poor. Clouds cover the sky. A device has been prepared. Instruments are ready. Maybe the weapon is on a platform. Maybe suspended. Maybe placed on a vessel. Maybe there are diagnostic aircraft nearby. We do not know. A countdown reaches 0. The device detonates. For a fraction of a second, a fireball appears. The ocean and atmosphere absorb the violence. Clouds scatter the light. A shock wave moves across the water. Sound enters the ocean. Radioactive products rise. Far above the Earth, 2 small optical sensors notice. First flash. Pause. Second flash. Data enter the satellite systems. The spacecraft sends the information home. The people who may have set off the device leave. No announcement. No flag. No photograph released. No celebration. Only silence. Or imagine the alternative. There is no ship. No bomb. No conspirators. No countdown. A tiny object moves silently through space near an old American satellite. Sunlight strikes an irregular surface. The object tumbles. Light reflects into 2 detectors. Brightness rises. Falls. Rises again. The satellite records a pattern eerily similar to the signature of a nuclear explosion. Down on Earth, nobody has done anything. Yet the United States begin searching the atmosphere. Analysts study South Africa. Officials worry about Israel. Scientists argue for months. Presidents read secret memoranda. Decades of speculation followed. All because a fragment of rock happened to turn in sunlight. One of those scenes, or something close to one of them, describes reality. That is the extraordinary part. The mystery is not that we lack theories. The mystery is that the theories describe completely different worlds. In one world, a state secretly crossed the nuclear threshold in defiance of international monitoring and escaped formal attribution. In the other, the world's nuclear warning system encountered a natural false alarm so convincing that experienced intelligence officers remained certain it had seen a bomb. Both worlds carry lessons. If it was nuclear, Vela demonstrates the limits of treaty verification and the power of plausible deniability. If it was not, Vela demonstrates the danger of placing too much confidence in one sensor signature. Either way, the incident mattered. But the first possibility carries a darker historical implication. How many events do governments know happened without being able to prove them publicly? Intelligence history is filled with probability. Leaders make decisions from incomplete information every day. Most of those uncertainties eventually disappear from public attention. Vela survived because the object at the center was nuclear. Nuclear weapons create a special demand for certainty. The world wants a clean list. Which countries have tested? When? Where? How many times? The September 22nd event refuses to fit neatly into that table. Maybe there should be one more nuclear test in the historical record. Maybe not. One flash separates the two versions. South Africa eventually dismantled its bombs. The Soviet Union collapsed. The Cold War ended. The Vela satellites disappeared into history. The original scientists grew old. Documents were declassified. New researchers reopened the evidence. But the core question remained exactly where it had been in 1979. What produced the double flash? There is something almost poetic about the name Vela. The satellites were meant to make nuclear secrecy impossible. Put detectors above the Earth and no desert, ocean or military border could hide a forbidden explosion. For years, they succeeded. Then one of them saw the event that surveillance was supposed to solve. And instead of eliminating secrecy, it created one of the nuclear age's longest-running mysteries. The machine saw enough to warn us. Not enough to convict anyone. Today, the strongest evidence still points many investigators toward a nuclear explosion. But history requires one final discipline. Probability is not proof. We can say the satellite recorded a nuclear-like double flash. We can say intelligence agencies took it extremely seriously. We can say one CIA assessment placed the likelihood of a test above 90%. We can say the White House scientific panel disagreed with that level of confidence. We can say later acoustic evidence strengthened the nuclear interpretation. We can say radioactive iodine and an ionospheric disturbance added further clues. We can say South Africa and Israel were investigated as possible actors. We can say President Carter privately came to suspect Israeli involvement. What we cannot responsibly say is that we know who pressed the button. No country has admitted it. No declassified document proves it. No surviving physical sample carries a national signature. The final gap remains. And that gap may have been the entire point. Because if somebody really did conduct a test that night, they accomplished something remarkable. They detonated a nuclear device under the eyes of an American satellite. They allowed the world's most sophisticated intelligence system to see it. They triggered investigations across continents. They left evidence in light, water and atmosphere. They may even have convinced the President of the United States. And still, more than 40 years later, nobody can stand before the world and prove who did it. At 12:53 in the morning, the satellite saw two flashes. The first lasted only an instant. The second lasted longer. Then the ocean returned to darkness. No declaration followed. No country took credit. No war began. The satellite continued around the Earth. And somewhere inside American computers, two small curves of light became permanent. A first peak. A dip. A second peak. The signature of a bomb. Or the most consequential reflection of sunlight in Cold War history. We still do not know with absolute certainty which. And whoever may have created that flash, if anyone did, has never told us.